Hey everyone, welcome to this explainer. Okay, so we are currently looking at a massive, and I mean undeniable, wave of AI agent tooling hitting enterprise infrastructure right now. If you've been paying even a little bit of attention to how AI models like Claude are connecting to real-world business systems, well, you've probably heard the acronym MCP thrown around. But here's the thing, as these technologies shift from fun little experimental side projects into core enterprise architecture, the stakes, they're getting incredibly high. So today, we're going to break down exactly how to build these systems securely. We're turning all that hype into a practical, bulletproof build guide. Let's get into it. Okay, let's dive into this. 97 million. Yep, you heard that right. That is the roughly estimated number of monthly SDK downloads for the Model Context Protocol, or MCP for short. To put that massive number into perspective, that is a staggering 970x increase in just about 18 months. Think about that for a second. MCP has crossed from a quirky novelty straight into foundational infrastructure faster than almost anyone anticipated. And right now, repositories built around it are absolutely dominating the GitHub trending charts. But you know, this kind of rapid growth brings a pretty serious warning. Adoption is outpacing controls, and when a protocol goes from being an interesting standard to the assumed default practically overnight, well, security teams are left scrambling. Actually, right now, an estimated 28% of Fortune 500 companies have already deployed at least one MSCP server internally. Yet, security consistently ranks as the absolute #1 blocker for broader enterprise adoption. Honestly, it's kind of the Wild West right now, and that is exactly where enterprise risk lives. So here's our blueprint for today. First, what exactly is an MCP server? Second, the 5 architecture layers. Third, phase 1, setup and scoping. Fourth, phase 2, validation and auditing. And finally, deploying for the enterprise. Simple enough, right? All right, kicking things off with section 1, what is an MCP server? Let's strip away all the buzzwords for a second. An MCP server is, at its absolute core, a lightweight, standardized backend service. It basically exposes a defined set of tools, resources, and prompts to an AI model through one single standard interface. You know, before MCP came along, if you wanted an AI to touch your database or maybe your ticketing system, it was a totally bespoke, custom plumbing job. You literally had to write a custom API wrapper and figure out a custom auth flow for every single tool and every single model. It was a massive headache. But now, you just build the server once using this protocol, and literally any MCP-compatible client, whether that's Claude, a developer's IDE agent, or even a custom internal chatbot, can use it seamlessly. Now, what's really interesting about this slide is how it separates reality from some really common myths. An MCP server is a real, live, running service. It's got request handling, authentication, and logging. What is it not? Well, for starters, it's not the AI model itself. The model is just the client in this scenario. It's also definitely not just some simple configuration JSON file sitting on your desktop. And perhaps most importantly, it is not automatically secure. You see, MCP defines the connection protocol, right? But it does not define your access control policy. That part, that is entirely on you. And that actually brings up another major point of confusion we're seeing in a lot of rising search queries lately, the difference between AI skills and MCP servers. So skills are basically packaged instructions. They tell a model how to approach a task, effectively shaping its behavior and its judgment. MCP servers, on the other hand, give the model actual physical access. They provide a live connection to real systems. To put it simply, skills change how a model thinks, but MCP servers change what a model can actually do. And for sure, any serious agentic setup in the enterprise is going to use both. Moving right along to section 2, the iceberg, which covers the 5 architecture layers. I like to call this the iceberg model, because what you usually see on the surface in this quick 5-minute tutorials is just a tiny fraction of what you actually need. A true production-grade server has 5 layers. Layers 1 and 2, that's the transport layer connecting the client, and the tool definitions exposing specific actions, those are almost never skipped. I mean, they're the fun part, right? So the crucial point is what happens next. Layers 3, 4, and 5, authentication to verify identity, resource scoping to limit data access, and audit logging. These are constantly, and I mean constantly, skipped in public GitHub prototypes. Now sure, that might be fine for a personal desktop setup, but for enterprise data, skipping the bottom of this iceberg is basically how you fail catastrophically. All right, let's get into the actionable stuff. Section 3, Phase 1, Setup and Scoping. Okay, step 1, define your tool surface narrowly. Seriously, do not give an agent a generic, wide-open database query tool if it really only needs to read order statuses. Remember, every single tool is a brand new attack surface. Step 2. Put authentication in front of everything. For remote servers, the heavily recommended approach here is OAuth 2.1. You want to tie every single request to a real, breathing user, never rely on some unauthenticated shared static key. And step 3, scope your permissions per tool, not per server. Think about it. If you have a server with a read invoices tool and an issue refund tool, those obviously require totally different authorization levels. Don't just blanket approve the whole server.
Which brings us to Section 4, Phase 2, Validation and Auditing.
Let's move to and see how this builds. Once your perimeter is set, you need some seriously rigorous operational security before you can even think about shipping this thing to production. First up, you absolutely must validate and sanitize every single input coming from the model. We all know models hallucinate, and they are highly susceptible to prompt injection. Next, log everything. And more importantly, tie those logs to an identity. When an AI inevitably does something weird, having identity-tied audit logs turns a massive panic-inducing mystery into a simple 5-minute investigation. Then rate limit. You've got to set blast radius controls, so an agent can only take, say, a few write actions per minute. Finally, test with adversarial prompts. Don't just run those happy path tests where everything goes right. Try to actively make the agent misuse tools or leak internal parameters. Think of it as the MCP equivalent of a mandatory penetration test.
And our final piece of the puzzle, Section 5, Deploying for the Enterprise.
So with over 9,400 public and internal MCP servers already out there, where do these things actually live? Well, here are the 3 most common deployment patterns side by side. First, you have the local pattern. This is super low risk, usually just running on a single developer's machine for individual productivity, like Claude Code. Then you have remote or hosted servers. These carry a medium to high risk. They're accessed over HTTP, and they are perfect for things like your enterprise CRM. But look down at the bottom row, the gateway or aggregator pattern. This one is rapidly becoming the absolute default for large platform teams. Instead of duplicating your security logic across a dozen individual servers, a gateway gives you a single, unified endpoint to enforce policy and completely centralize your governance. All right, to summarize where we are right now. As of mid-2026, there is no credible replacement for MCP. None. It is the dominant standard. The trend we're seeing in the enterprise is all about maturation, basically hardening those existing servers, not replacing the protocol entirely. Look, getting a server to just run, that's the easy part. Adding real authentication, carefully scoped permissions, and full audit logging, that is where the true engineering value lies. By the way, if your team is scoping an MCP integration and you feel like you need a second set of eyes on the architecture before touching any real production data, you can always reach out for a full architecture review over at 200oksolutions.com. I want to leave you with this final provocative thought. Take a hard look at your own infrastructure. Based on the 5 layers we discussed today, is your AI agent a well-governed productivity asset, or is it a liability report just waiting to happen? Secure the plumbing, enforce those protocols, and build with absolute confidence. Thank you so much for joining me for this explainer, and I will catch you on the next one.